In the previous tutorial, we looked at extracting colors from an image and using these values to drive a numeric range. In this tutorial, we're going to go in the opposite direction and take a series of numeric values and use these to drive a color override in our view. And to do this, we're going to start with our Excel base file. You can see here we are without adaptive components arrayed. I'm going to hit Run to generate the adaptive components. And if you run into an issue here, you can see I hit Run and our adaptive components were not arrayed. There's a little bug in Dynamo where some of these drop-down menus sometimes need to be copied and pasted to requeue. So if I plug these in, if I copy and paste the family types and plug that into our family symbol, now if I hit Run, we should have it working. So now we have our adaptive components on the roof, and again these are rather abstract as they're 2 meters thick. But I'm going to delete this previous family types dropdown. And remember, we have our adaptive components, and we have our polygons, as well as surfaces, which are in the same list order, except these polygons exist within Dynamo, and these adaptive components exist within Revit. Now we're going to use this Dynamo geometry to analyze certain parts of the surfaces and use them to drive colors that we're overriding within Revit. So in order to do this, we're going to use the override color in view, which we've used before. If I type in override, I can drop this onto the canvas. This will be the last step in the process, so I'm going to move this farther to the right. And now I'm going to maximize the Dynamo viewport. So let's zoom in here. And what we want to analyze is something interesting about this geometry. So let's start with the area of our surfaces. If I clear the search bar here, I'll type in area. You can tell I can query the area of a surface. So we can see this Dynamo geometry. Let's click down here on Geom, go to Geometry Space. Now that we've zoomed to fit, I can drop this into the upper right corner. Zoom out a bit. And I'll go back to node space. So now that we have our surface area node on the canvas, we can plug our surface into its input and hit Run. And here we have an array representing the area of each surface. There's going to be subtle differences as it's a doubly curved surface. So how do we turn this into a color? We have a series of numbers and we want to map these to a color domain. Now we've used the Remap Range component before, which allows us to remap numbers to another domain of numbers. And we have something similar in Dynamo called the color range, which allows us to map a series of numbers to a gradient between two colors. This is a very helpful node and it's nice and easy to work with. I'm going to minimize our outputs on these 3 nodes. This is asking for our list of values, which will be our surface area. And then from this list, it's going to take the minimum and maximum value of these area, and it's going to map those to the start color and the end color and create a gradient between those 2 colors. So let's clear the search bar and create some colors. I'll type in color. Let's go to Create by ARGB. And this is going to be values of alpha, red, green, and blue. So let's pull up a slider. Integer slider, we'll drop that onto the canvas. And these values will be between 0 and 255, so I'll change our max to 255 and minimize that domain. And let's just make this slider 255. So let's make this first color green. I'm going to plug 255 into G, and the others will default to 0. I'm going to copy this color, drag it down for our second color. I'm going to unplug it from green and plug our 255 into R for red. So we have our 2 colors now. One more thing worth noting is if I hover over value, this is asking for a value between 0 and 1 of the selected color. And you can see our surface area, we have values not between 0 and 1. So we need to remap this domain to a list of numbers between 0 and 1. In order to do this, we'll use the Remap Range node. So I'm going to select these two nodes and drag them to the right. Let's clear the search bar and look up Remap. I'm going to grab the Remap Range. And let's plug our surface area into numbers. Let's move our colors down a bit. And move the Remap Range down a bit. And I'm going to clear the search bar and let's just do 2 number nodes. We're not going to be changing these, so there's no need to do a slider. We're just going to make a 0, and copy and paste, and a 1. So these values relative to one another will be the same, except they're remapped from this list of areas to a list between 0 and 1. So that'll be our value. We have our start color, and we have our end color. I'll hit run. And we don't have an option to view the output, so I'm going to do the old-fashioned way. I'm going to clear the search bar and look for watch. Drop that onto the canvas, plug our color into input, and hit run. So now we have a list of colors on our outputs which correspond to the area of each element. And in order to test this to ensure that it's working properly, we want to actually view these results in Revit. We've done all the legwork here. We've done 2 remaps, one way of remapping the number, and then translating that remap to a color range. So I'm going to clear this watch. I'm going to drag this override color in view, which we set up at the beginning of this lesson. And I'm going to plug our color into the color input. And all the way back to our adaptive components at the bottom here, we have our adaptive component output. These are the Revit elements. I'll plug that into element. Let's go to Revit and zoom out a bit so we can see the results. And I'm going to hit run. So we can see this makes sense here. We have a series of values where red represents the larger areas and green represents the smaller areas. There's a subtle difference. But you can see you're starting to get some information from the way this surface is generating our quad panels. Now, we have all of the difficult stuff set up with our color gradient and our map range. So rather than doing area, suppose we want to evaluate the deviation from plane of this panel, which is likely more relevant for construction. I'll clear the search bar and type in deviation. Let's go to plane deviation, drop that onto the canvas. You can see this input is asking for a polygon, and we have our polygon set up by creating the polygons from points. So I'll plug our polygon into here. Let's hit run. And we have a range between 0 and 1 for these polygons. Now, since this is already a range between 0 and 1, we really don't need to plug it into our remap range. But since this is already set up and we can plug in any list of numbers to this remap, I'm just going to plug it directly into there. And let's hit run. So now we have our panels colored in a way that shows us the maximum plane deviation, which makes sense with the geometry here, and that we have significant plane deviation at the corners. We have no plane deviation in the middle axes of this surface. And that's starting to become clearer here. So we could imagine overriding these colors in a view and then dropping this view onto a Revit sheet for documentation. What we may want to add to a sheet like this are a series of spreadsheets which represent something like deviation. So in the same way we imported Excel spreadsheets to create our numbers all the way back here, we're going to export these deviation values in line with the color code. So we'll have written values to Excel in preparation for documentation. So stay tuned for the next lesson.